Hey, thanks for taking the time and going through this session with me. I hope you're enjoying the event and you're learning tons. So, today we're going to be talking about addressing the unspoken complexity of multi tenancy on Kubernetes, right? Now that you know how to spin up your clusters, how to manage these clusters, you feel confident in the infrastructure space. Now comes the challenge that you are onboarding more applications and you're onboarding more developers. And with that comes different complexities, right? And today we're going to be talking about some of the challenges around addressing those complexities and how layering on top of your clusters a developer platform or an application platform can help you address some of those challenges. Before we go into the presentation and the demo itself, a little bit about me. Who is Bruno? I think today I'm probably the person suffering from all the Disney movies. If you have kids, you probably understand at this point that Disney really doesn't like Bruno with all their kind of "we don't talk about Bruno" songs. But other than that, as you can see, I like to say I'm a failed musician. Was not good enough to make the cut into kind of professional musician. Switch it up to software engineering, not good enough as well. But now, too late for a rock star life. Losing hair, putting weight, chances gone. But I'm one of the founding members of Shipa, which is a cloud native application management layer for Kubernetes, right, or an application layer level API. Shipa is my second venture. Had an opportunity to do another venture as well around cloud native space as well, but more towards the infrastructure. And that startup got acquired back in 2018. So I've been fortunate enough to be around cloud native for a few years. You can find me on LinkedIn as well as you can find me on Twitter, and happy to connect with you on both ways and kind of answer any questions you may have. But moving towards the problem itself, right? Now that you've got your clusters under management, let's say you have your clusters being managed using Rancher, now part of SUSE, and you have your clusters, you're spinning up your clusters across maybe even EKS, GKE, or self-hosted clusters, for example. And now you're onboarding more developers and more applications. Those that you see on your screen are some of the most common challenges we see around multi-tenancy, right? The first one is multi-cluster visibility. And what do we mean by multi-cluster visibility? Because yeah, Rancher gives you the multi-cluster visibility, but now you have multiple users deploying multiple or different applications across different clusters. So how do you start bringing that multi-tenancy visibility and understanding on top of on a centralized location that you can manage applications and users in an easy way at the right level, right? The second point is your RBAC. Now that you have these applications being deployed by multiple users, you want to make sure that you segregate who can have access to what, or who can deploy what, and who is part of a development team, or who is part of a DevOps team, or platform engineering, for example. And most importantly, how to connect that, for example, to your Microsoft AD, right? Or your Azure AD, your Active Directory, or your SAML based authentication. We all know that handling Kubernetes authentication is extremely complex. And at the end of the day, you want to push out your users out of your clusters, right? You don't want to have your developers accessing your clusters and messing up things. The other part as well is as you deploy or your developers deploy these applications, you want to make sure that applications are isolated from each other. You don't want applications being able to communicate with each other, or in case there is a problem, you reduce the blast radius, right? You want to make sure that applications or anything that happens to that team, for example, all is contained within their own environment. And last but not least is to address multi-tenancy properly, we all have to implement policies. And policies today, most of the approach available today is very infrastructure centric, right? Rather than being application centric, which at scale, as you scale across multiple clusters, multiple pipelines, API versions, and other, causes confusion and problem for you to scale. So today we're going to be showing a quick demo on how you can address these points on top of your clusters that you may or you might be managing using Rancher. So for us, we are going to be using something similar to this, to the architecture that you have in front of you, and explaining a little bit about it is we have two clusters. I'm going to be using two GKE clusters for this demo, but regardless of the cloud provider you're using or cluster provider, you can replicate exactly the same, right? I'm assuming your clusters are already created. If you have created your clusters using Rancher, or if you used the cloud provider directly to create those clusters, for example, I'm starting from the point that you already have these clusters in place. They are running, and now we are going to start onboarding people and applications in a multi-tenant format. For that, we're going to be using Shipa, the Shipa API, right? And Shipa will work as an application level API as well as a developer platform that you can lay on top of Ranger. Everything that we're going to be doing here, it's available as on a free model. You can start, and it's available on a SaaS format. You can access Shipa under apps.shipa.cloud. Again, apps.shipa.cloud. Or you can also run Shipa in your own environment. There is an option to install Shipa, the Shipa control plane, in a self-hosted environment. As well as if you're using Rancher to manage your cluster, Shipa is part of your Rancher marketplace. So you can have Shipa installed directly from there at no cost. And we're going to be using Shipa to centralize our application and user information. Just like what we mentioned before, we want to make sure that we get our developers out of our clusters. They don't need to access our cluster, right? We learned with SSH that it's not the wisest decision to have our developers access clusters directly. So we're going to be using that as a way to give developers our portal where they can manage their own applications, as well as a way for us to manage our developers and our teams. Because Shipa works on top of your Kubernetes cluster APIs, Shipa will vet and will help you address the multi-tenant issues that we talked about before. So let's get started. If I go into my my dashboard here, I'm gonna have. Let me just move this out of the way. You're gonna see that I have my GKE screen here open, and I have one cluster available here. I actually have app cluster 2, and I also have an app cluster 1. We'll see shortly, trust me. And on my terminal, I already have my kubectl, kubectl, kubecontrol, whatever you want to call it, connected to that cluster, right? And I just ran a get namespace, and you can see that I'm already connected, and there's nothing installed in that cluster. It's basically a blank cluster. Let's say you just created a cluster using GKE or using Ranger. The first topic that we can address, we have the multi-tenancy part, right? The user or RBAC part. On top of that, as I mentioned, I'm going to be using Shipa, and you can sign up again on apps.shipa.cloud. So I created my account, I log in. What is the first step for me? Is to start inviting my users, right? I have two ways. I can use the Shipa authentication itself. So that helps me to start getting my users out of my cluster so they can manage their applications without having to log into the cluster. Or if I want to quickly connect Shipa to my SSO provider, I can come in here and say settings, for example, and single sign on. Directly from here, you can connect your provider. So everything that we do from here, if you're connecting your provider, you can pull your users from Azure AD, for example. So once you have done this, if you do desire to do this, this is not required or mandatory, it's optional. And it provides you a great and easy way to connect to your AD, right? So by all means, if this is an enterprise requirement for your company, it's available. But once it's done, I can come here and under user management. Under user management, I can quickly invite my users just by entering their email address. Pretty innovative, right? Nobody has done this in the past. Ta-da! So you can invite your developers and your other DevOps or platform engineering team members or friends, colleagues, or whatever you want to call them. And you can invite them here. And what we have pre-built is basically three roles, right? Or three basic roles. We have built an admin role, which is basically someone like you who created the account, who has access over everything. The second is the operator or DevOps. This is the person that can create multiple environments and add more users, for example, but has a limited scope. So if you want to add other folks in your team, but you don't want to give them access over your subscription and so on a Shipa perspective, this is the best place to start. The other one is the developer. So this is the person who is going to be deploying and managing their applications. So this is those are pre-built roles you can customize using the Shipa CLI. You can add more roles, but this can help you get started quickly. And once you can add teams as well directly from here. And once you start adding your members, your different members, you can assign some of the roles for those users. So if you added user one at organization.com, for example, you can just add that user as a DevOps or a developer, for example, and as a part of a team. Easy, right? How much Kubernetes did you have to know to do this? 0. And that's the purpose, right? Quickly get up and running and quickly onboard your users. Awesome. Now, what is the second part? The second part is the resource isolation, right? Now, okay, Bruno, I've added my users. What do I do from here? Now these users are going to need to have different environments. And how do I connect this thing to my cluster, right? This is where we come into what Shipa calls frameworks. You can call these policy frameworks or just policies. As long as it makes you happy, just go for it. But when you think about frameworks on Shipa, think about it as a set of policies that you, DevOps or platform engineer, you're going to define, and it's going to connect to your underlying cluster. These policies, or these frameworks, when you connect to your cluster, it's going to become a namespace in your cluster grouped by those policies that we define here that you're going to see in 1 second. Now, this is the middleware per se between you defining these policies and connecting these policies to your cluster, a namespace in your cluster. And now this is going to become the interface between you and your developers. And think of policies and frameworks on Shipa as a way to address different requirements, be it development, staging, and production environments where you can create one policy for each. Or it can be maybe a framework called Project 1, Project 2, Team 1, Team X, for example. So the world is your oyster here, and you're free to play with different scenarios and build your multi-tenancy environment addressing the security requirements for each environment, right? So let's see how we're going to do this. If you come here into frameworks and I click on create, I am gonna have a couple options here. One is deploy applications with reasonable defaults. I'm just getting started. I want to get this thing up and running, and I want to get value out of it as fast as possible with less amount of policies to be concerned about. This is your choice. Second choice is discover existing applications. And what discover existing applications do for you is enable you to connect this framework to an existing cluster that you already have running with applications running. So you can give your developers a developer portal for them to manage and support applications. And you're going to understand it a little bit and also see how these applications comply with your security policies. I can show you an example soon. And the third example, which is the one that we're going to be running through today, is define detailed policies. Again, if we think about framework as an isolated environment grouped by policies that we're going to connect to our clusters, we want to make sure that we address a couple points that we raised before. We can define policies without complexity, and we can isolate the resources without complexity, right? So let me choose the third one. And you can see that directly here, it opens up a few options for us to isolate everything. And we're doing this from the dashboard. And while we're doing the dashboard, you can also create frameworks and manage everything using your infrastructure as code tool or pipeline of choice. So everything that we're doing here, you can do using Rancher's Fleet, for example. You can use Argo CD, Flux, you can use Terraform, Pulumi, cross-plane, Ansible, if there is anyone using Ansible still. I think the only plugin that Shipa does not offer, at least right now, is Puppet and Chef. But I mean, why, right? So if we go here and we do next, the first thing that it's going to ask us is going to be the name. And we can do it, for example, project one dev Susie. Oops, if I can type. Great, this is the name. And again, you can use this to address development, staging, production, project one, project X. Go nuts. And here you can see the Kubernetes namespace. Kubernetes namespace, every time you connect this framework to your cluster, or you connect a new framework to your cluster, as mentioned, it will become a namespace in your cluster. So if the namespace does not exist, Shipa will create one. Or if you want Shipa to connect this set of policies to an existing namespace, you can just mention the Kubernetes namespace here of an existing namespace in the cluster you want it to be connected. Good? Awesome. So we're going to do next. Here, you're going to separate the resource consumption, or you're going to assign resource consumption limits. You can create your resource consumption limits under plan here on the left menu. I have created two, one called dev, one called prod. And if you just created your account on Shipa, or you just installed Shipa using the Rancher Marketplace, you have one called Shipa Plan, which is unlimited resources. You might not want that option. But what it means is that every application deployed using this policy will get this limit across memory and CPU, for example. I'll do next. Here is your chance to invite the teams that you previously created that we just talked about. So you could add your different teams, development, project one, project two, or whatever that you have created as a team. So that means that the teams that you add here are the ones that are going to be allowed to deploy their applications and using this framework, right? So now you can assign different frameworks to different teams, and they don't know if you're using GK, AKS, RKE, or whatever. They only care and pick a policy, good, or a framework. The next step is for me to define how to scale. If you're running production-based workloads, you want to make sure that these workloads are not only isolated, but they scale properly. So you can set auto scale here and say, hey, every application deploy, let's say this is a production. You want to have a minimum of 2 replicas, right? Production-wise, never having 1, 2 plus is great. And you want to have a maximum of 5 replicas. So this puts a limit on how much an application can scale. And you can see every time it scales every time it reaches 85% of a CPU. You're setting default scalability for applications deployed, so developers don't have to be concerned about it. Now, if you want to set default ones, but you still want to give your developers a way to customize it, you can just check allow app level policies. The next one is registry control. Again, if this is a production environment or you want to keep things locked down, you can just say, hey, I want applications deployed using this framework to only allow applications coming from docker.io, Shipa software. If any other pipelines or developers try to push applications or images that are coming from other registries other than this one right here, just block it, right? Shouldn't be allowed. Or if you want, you can just remove it. If you remove it, you are going to allow users to pull images from anywhere, basically. Here, if you're running clusters with large amounts of nodes, for example, and you want to separate clusters, maybe separate nodes, and you want to say a certain amount of nodes should only go to this type of applications, or these applications for this framework should only go to GPU-based nodes, for example. So you could say project one, for example, GPU nodes, project one, or whatever you have from a node label perspective. As long as those labels are placed in your nodes, when a developer deploys an application using or pointing to this framework, Shipa will search for that node in your cluster and deploy these applications on nodes where you have this label. Now, the second one is allowed CNAMEs. So you want to make sure that developers deploy applications, they don't try to be funny and try to expose their applications on app1.google.com, and then they text you or they Slack you saying, my applications are not working. Why? Right? So you can come in here and say, hey, only allow applications to be exposed under star.shipa.io. Great. Or if you leave blank, they can do .google.com. It's your choice. The next one is enforce network policy. Remember the isolation problem. If we want, we can say, hey, applications deployed here should get a default network policy. And same as the scalability. If you want to define a default policy, but you want to allow your users to still make changes to it, you can do this here. You can define ingress and egress as detailed or as high level as you want, right? You can go from deny all the way to saying, hey, applications deployed using my project one policy should only connect, if I can type, please, to applications deployed on this other framework, right? Or this other policy. Or it can be more granular. They can only connect to applications you deployed using this framework, but only application Magento. Only on port X, right? So you're defining very tight security requirements here and resource isolation. Or if you want, you can just say allow all. And same thing for my egress, right? You can do allow all, deny all, or super detailed policies. Last but not least is, or almost last, I should say, I want to define security scans. So you can say, hey, every time an application is deployed using this policy or this framework to that namespace in my cluster, only allow glibc, for example, to go as a vulnerability exception. Anything else, block the deployment, right? Or if you want, you can disable the scan. The next part and last part is if you are connecting this framework to an existing namespace in your cluster where you have applications already, you could set labels here, for example, for applications that you already have deployed in that namespace. So Shipa, as soon as the cluster is connected, Shipa will scan that namespace for applications or objects with this label. In case you have none, you can just define it as 0. You can do create, and you can see our policy project one dev SUSE is created. But what do you do with this thing, right? This is just sitting on Shipa with my users sitting on Shipa. How do I bring this all together into my cluster? And that's the cluster connection part. If we go to clusters and we do create cluster, you can see that it picks an available policy. If you have multiple policies or frameworks here, you can choose multiple frameworks to connect to the same cluster. So you have that set of policies defining a framework that it's isolated from everything else with resource limits, network policy, security, and all RBAC and all of that. And you can create multiple. You can create project 1, project 2, project 3, or dev, staging, and production. And you can connect them all to the same cluster. And in a few seconds, you're going to see that when a developer is pointing their applications to deployment, they're pointing to a policy. So that's how Shipa knows exactly where to deploy. Here, because I only have one policy created, or one framework, I only see one option, but you get it, right? What I need here is my Kubernetes control plane, so which is basically my API URL or IP. If I just come in here and I do this, and I paste it here, and I click on generate command, Shipa will generate this command for me, which is a kubectl. If I copy this and I run this on my terminal that is pointing to the cluster that I want to connect, right? What's going to happen is Shipa will start implementing its agent in that cluster and creating the account and the services that needs to run for Shipa to connect to that cluster, monitor deployment, so on and so forth. This process should take around 2 minutes, maybe 1 to 2 minutes. And while it does that, I'm going to give you or show you the developer interface. You now addressed RBAC connection to your AD. You assign role-based access to your developers and your DevOps teams. You created an environment, right, or a framework, and you connect it to a cluster that is isolated and has resource limits, and you address policies. And most important, how much Kubernetes did you have to know? Zero, right? I was defining policies, and I don't care about how complex Regal or Caverno or whatever other solution you're exploring it would be. In this case, I'm defining it in plain English per se with an application focus, and I'm connecting to whatever infrastructure. If you want to move to a scalable model, you have to start moving towards an application view or application centric approach rather than on a cluster by cluster base or cluster version and so on. So this is how you can quickly do. You can quickly onboard other folks on your team, even if they're not extremely experienced on Kubernetes. Awesome. So while the cluster connection is running here, I can come into applications. Let's say you gave access to your development team, right, or a developer. This is the interface your developer would see. Now, the deployment can happen using Argo, can be using Flux, can be using Helm, or whatever you're using, right? This is an interface that you're going to see, and this is kind of very similar to what they would be running from Terraform. Here, a developer would say SUSECON, for example, or the name of the application. And here's the thing, right? Now, instead of seeing clusters, what your developer is going to see is or are the frameworks that you gave them access to. So now I can choose, for example, dev environment or whatever you create and gave access to your developer. That's my interface between me and my development team. So everything they push is going to be going towards that framework, which is connected to a specific namespace. So it's going to go to that namespace, and it's going to be protected by that set of policies. If I'm part of multiple teams, I can select which team I want to be the owner of that application. Here I can enter my Docker image, for example. And if you're using private, you can enter your credentials and so on, but to keep things simple. And directly from here, you can set environment variables for your application. You can customize the port where it is exposed. For example, if I just set an application variable here, I can say var1, it's test, and I'll click on deploy. And again, you can see that I'm doing zero Kubernetes, right? I'm focusing on my application. I'm pointing to a policy or to a framework, and I know my resources are getting isolated by effect. I can see my SUSECON app already here. And if I go in here now, you start giving your developer application level information. If they see the map, for example, they can see, okay, here's my bulletin application. And here's the secrets used to run this. Here are the services used to expose and the details. So now if there are problems with the application, their application is isolated and they can properly view and support their applications. You can see the images that are being used later as a DevOps or SRE. You can see where applications are being exposed. You can see the lifecycle information, such as what happened to the application, right? When it was deployed, environment variables that were set, and you can see the log associated with that activity. So now you have complete visibility over that. Last but not least, you can see how this application is being exposed. Remember that we set allow all. So you can see this being exposed here. If we customize it, we're going to see it updated. And applications are basically accessible here. Awesome. In just a few minutes, we built a framework or a policy. We addressed RBAC multi-cluster because you can start connecting multiple frameworks to multiple clusters. And you took your developers out of your cluster and you addressed a whole bunch of things. Now multi-cluster tenancy and control is easy on top of your cluster. I hope that was helpful. And again, feel free to connect with me. I'd love to hear from you and answer any questions you might have. Thank you, and I hope you enjoy the rest of the event.